So ALP Aeroflex is into the innovative insulation solution. These are the few details related to the ALP Aeroflex. They have the portfolio of over 10,000 products and global presence over there, founded in 1985. Key certification you can see over there, key projects they have done in airports, hospital, IT sector, industry, government, educational institution, prestigious international projects they have done. You can see over there. So these are the base product line for ALP Aeroflex, Aeroflex Aerocell, Aeroflex Eco. Below are the contact details for ALP Aeroflex. If you have any queries, you can directly contact to the ALP Aeroflex regarding insulation solutions. So going further, I welcome again every participant and speaker for the day, and Priyanka ma'am over there. I request Priyanka Jan ma'am to introduce the speaker in front of us and audience. Over to you, ma'am. Thank you very much. So one more thing, yeah, sorry ma'am. One more thing, further, if anybody have any question, they can put there in chat box, or better you can put in Q&A section. We'll take it at the end of the PPT of finishing, sir. Thank you, ma'am. Thank you.
Thank you, Tapas. It's such a nice topic which Mr. Ganeshan is going to take, is earth-friendly green refrigerant. As R32 is banned, and gradually its production will stop. So it is very important to understand what is green refrigerant and what are earth-friendly green refrigerants. So was just tell Mr. Ganeshan is based in Bangalore, currently handling technical and service support for Commercial Applied Services Division of Carrier Air Conditioning and Refrigeration Limited, one of the leading HVAC manufacturing companies in country. He started his career 42 years back with Voltas Limited. It was again a leading manufacturing and contracting company in India. During his 26 years association with Voltas, he worked in various positions in many different cities, branches in India. Therefore, after that, he moved to Carrier, and he has completed 16 years of in Carrier and has been handling technical and service support operations. He has traveled to various countries and has been trained in many new generation HVAC products like centrifugal, screw and absorption chillers, specialist in handling variable frequency drives and high voltage range of chillers. So I welcome you, sir, and will be waiting to listen to you, and it's all to you, sir. Thank you.
Yeah. Thank you, Priyanka. I'll share the screen. Suppose I can share my screen.
Please go ahead, sir. Please.
Can you able to see the screen?
Yes, sir. Yes, sir. It's fine. Yeah, perfectly fine.
Okay. Very good evening to you all. Okay, and welcome to this today's evening technical sessions. This is on earth-friendly green refrigerant. Yeah. So it's coincided correctly with the Earth Day special. In fact, now we started the same thing last year here in Bangalore, and the right subject is today what we have selected, and we definitely wanted to share whatever we have learned from these industries, and we would like to share with you in that case. Yeah. So today we will cover up the overview of the standards on the refrigerants and then applicable regulations, then the decoding the environmental impact which is going to have, and what are the current choices we have here. And then as a whole, we are all responsible of holding this responsibility, how we are going to move this transition. Okay, so let's go to a little bit of the history. So history, it is 1834 is the modern vapor compression process started. But it started with natural refrigerants like CO2, ammonia, and all those things only it started then. Then subsequently from 30 to 50, then the modern refrigerant started like 22, and then it went into 70, 80, then we come into the CFC and HCFC. Okay. Then during this period, then we have noticed that there is these modern refrigerants are giving some problem, especially on the ozone depletions, which we'll take further details. And then subsequently during 18, then the whole thing is formed at HCFC or the case. In 87, then the rise of the hydrofluorocarbons, especially on the ODP and as well as GWP has been identified in the case. So 1995, the global warming potential has been become an issue. Then 1997, actually during 87 itself, there's a Montreal Protocol has been started. We will discuss a little more in that. So 1997, the Kyoto Protocol. Then in 2016 is the Kigali Agreement, which is an amendment of the Montreal Protocol. We'll go a little more detail into that. And in today's present 2020, so we are with the HFO, which is the current refrigerant, which is being discussed now. So the refrigerants, we all know that there is, if at all, if you wanted to go for an ideal refrigerant, so that should have a complete environmental impact. So it should take care of the environmental impact, which currently we are undergoing. The sustainability, then of course safety to use on the refrigerant and as well as the human being, and it should be available with the cheapest cost, and its performance should be there to take care of the energy efficiency case. Yeah. So in ozone depletion, so what is the ozone depletion? Basically, the chlorine and bromine atoms, when it comes in contact with the ozone layers, we all know, so it is there above, which is protecting us from the ultraviolet rays, which is just coming from the sun. So in that, there are two, one is A and the ultraviolet B. So the ultraviolet B is definitely harming to the human being if it is directly come into the atmosphere now. So scientists have discovered during 1970s that these, whatever the modern refrigerants are interacting with the chlorine and bromine as interacting with the ozone, and then it is absorbing together and for making a small hole into that now. So that can really a problem to the human kind, because it can lead to the skin cancer, eye cataracts. So there are many issues which can come. So then the whole ozone layers, these are actually the ozone layer is the filters protecting us from the ultraviolet rays now. So ozone concentration is measured in Dobson units. The lower the units, the lower the concentration of the ozone now. The whole zones in size is shaped during the years due to the weather. It can change, can change to the weather and as well as to the climate factors now. The overall size is getting smaller healing. That's a good news is there that yes, during 30 years when the scientists have been checking that, and it has definitely started healing. The whole sizes are coming smaller and smaller. But that is not the real big issue now. Let us understand a little more on this now. So after understanding that the refrigerant, modern refrigerants are giving issues, then we have identified what are these ozone depleting substances. Then that has been how it is going to be measured. So And ODP is a value basically from 0 to 1. If you are seeing on substance, 0 is a no depletions, but 1 is the highest depletion. So then it measures relative to the degradation of the ozone layer compared to the R11. So R11 is the highest one. If you see that 100% is R11, then R22 can give a damages to the 5% over there. And the same way R20, 123, it can go up to 2% now. But whereas if you see 134A, R410A, these are all 0 ODPs over there now. Okay. So then further to that now, see, actually there are many protocols in international treaties has been working on this, how to bring down the issues of refrigerant damaging our atmosphere. So then the 1997, so it is aimed to reduce the global warming potential actually. So it's called reducing there are 6 greenhouse gases that has been giving the issue of warming the global warming effect in that case now. So we all know basically sunlight passes through the atmosphere. So whatever comes actually, then Earth is radiating the infrared radiation. So that has to go back into the atmosphere. So what is happening when the heat which is absorbed by the Earth, if it is not going back, so then it can cause the impact by increasing the surface temperature of the Earth. So even though the CO2 is there just to allow us to go back the ultraviolet radiation, but whereas now the greenhouse gases which is there, all are forming a sort of a screen. So that is with the results, the Earth's temperature started rising now. So this has been found, and then the Kyoto Protocol was trying to address this issue. But unfortunately, this was not fully gone into the full stream over there now, because of there are many reasons into that now. Basically, the developing countries are not approved into that, and the cost of the it was going as high as around 716 billion to implement the whole thing in that case, and there are a lot of disconnect with all the other countries. So that's why it never took off over there now. Subsequently, to build between the Montreal Protocol and the Kyoto Protocol, then a Kigali Amendment after understanding with various countries and to manage in between there. So this has been started. So this has been implemented in 2016. In around 197 countries has adopted this. This basically addressing the phase down of HFCs now. So, and during that discussion, there are some very various points has been discussed now. Okay, we can go into that all the points. It's very big thing. So these are all around key points which has been discussed, and they will address that the HFC should be slowed down, and then we need to develop a new refrigerant. So that should handle both the ODP and as well as the GWP in the case. Now, in this Kigali agreement, what they have discussed and agreed is there are 2 categories will be there. Group 1 is developed countries, and group 2 is the developing countries like us. If you see that group 1 is most of the article particles like US and European Union and other countries. So if you see that group 2, so like Bahrain, India, Iraq, and Middle East, Pakistan, and all those countries are there now. So here in this country, in this what they had identified, they are supposed to phase down the steps by comparing with the group 1. If you see that now 2024 is the freezing date for the group 1 countries, but whereas 2028 is for the developing countries like us now. So from that is the basis on which moving forward, each countries have agreed to phase down. That means that it stopped consuming and as well as reducing the consumption of these GWP, that means greenhouse gases, by, if you can see, step 1 maybe around 10%, step 2 30%, step 3 50%, and step 4 is around 80%. So finally, at the by 2040, if you really see that, so everybody has to bring down to level 2.0. So this wasn't agreed by all the countries. Now, how did you measure this? Basically, they wanted to measure a common unit. So what they made it is, so they have taken as the CO2 as a basis. Now, for instance, now R12 GW is 10,900, which is equal to around 10,900 pounds of CO2 equivalent. So of course, on the 100-year basis, this has been measured. Like every gas, every refrigerant has got a different GWP. So what is India done in this now? So India, as on date, there's no law, but as such, but India has taken a lot of proactive steps here. Under the Ministry of Environment, Forest and Climate Change, they have already formed Ozone cell and formed and empowered the steering committee with a project managing team and a standing committee which meets often, and standing committee which are monitoring what is really happening now. And over and above, so they are also monitoring the gas, how much is being imported, and both in imported as well as domestic consumption are being monitored now. In addition to that, the voluntaries like the CII, IGBC, USBCC, ISHRAE, all are also collecting all these data, and which will be used for the future. So how do you do this now? Basically, there are two things is there now. One is phase out and the regulations now. So we have seen that phase out has already happened only on the CFCs. You know that CFCs are all a more damaging one, which is basically on 11 and 12, which we all know that it has been already phased out from this. But even HCFC is there also, that also has from last 2019, I think so. So that also has out from our India also started making any product which can use on CFCs and HCFCs now. But subsequently, the regulation is started on the HFCs now. So basically, our target on the ODP is specific refrigerant, but whereas in the GW regulations is now specific equipment application here now. So countries implementing is basically based on the timing and the development, but whereas here each country is to meet a direct CO2 equivalent limit as per the chart which has been shown earlier now. So the restrictions is now they restrict the new consumption, not production basically. Okay, and the results now, so complete elimination of CFC, HCFC is already done now, and now we have already started reducing the greenhouse gases emissions, example of equivalent to our CO2 now. So now the challenges come to the industries for now. We need to develop a new refrigerant now, okay, which is not as simple as okay straight away replace with this. Okay, if you see that now an ideal refrigerant has to undergo or has to pass all those things to start with, toxicity, flammability, then equipment capacity, then it should be available throughout the global. And also equipment energy efficiency, it should be energy efficiency should be there, otherwise we'll consume more power. Then when we use this particular refrigerant, then the equipment footprint that I need not go for the higher size compressor just for changing one refrigerant here. Of course, material compatibility, this refrigerant passes through the complete refrigeration system, including copper, steel, whatever you call Teflon. So this should be compatible with kind of materials here now. Then it has to be undergo this building code adoptions in respect to each and every countries here. So for instance, safety, if you safety, you see that now there are two scales are there. One is the toxicity and the flammability should be there. So each and every refrigerant should, the A1 is the best, the best. But if you see that A1, how many refrigerants are there now? R32, which is already gone. 410A is there, which is under regulation now. Then 123, 4 is that so these are all the latest one which has come. HFO refrigerant which has come. 134A is under regulation. So here are the challenges now. So out of this now, what we should select here and as a replacement or as a retrofit here now. Okay. So again, in our systems, we have two type of system. One is a direct system, other than indirect system. Indirect system is like chillers are all we call. So we just have a contained refrigerant here and then circulate the chilled water. But whereas in direct system like our split unit and other units and all, it is directly, the moment it leaks, it is going into the atmosphere or it is going to the occupied zone here. So that's why now there are many standards are there with respect to the handling of the refrigerant now. So if you see that completion basically on ISHRAE is there, ISHRAE 34, 15, the UL codes, building codes, plus in addition to that local codes are there. So which are all just to undergo all this test before we started using this refrigerant here. And even if you select anything, anybody is developed on a new refrigerant, but everybody has to undergo this process now, including the ISHRAE has to give this code, then equipment standard, it has to be available, then application standards, ISHRAE 15, then building codes, then local codes here now. So currently, in addition to that, the major importance is the toxicity and the flammability. So what is exactly the direct and indirect importance? So we have been earlier, we have been only talking about the gas leaks, which directly goes and it affects the atmosphere and then making the global warming impact and the ozone layer depletions now. But that is, if you really see on the global warming protection, if you see that it's only hardly 2% the gas leaking can impact now. Whereas, what about this 98%? What we call is is basically on the efficiency of the chillers, right? From for running the equipment now, we need to produce electricity. So even right from making the electricity to transportation and then bringing to and consuming all the electricity, all has to be in an efficient manner. Otherwise now, so this is basically consuming almost around 98%. So that is what we call the total equivalent warming impact. It is not the 2% which currently earlier we were been discussing now, but the industries are now working on that. The balance 98%. How do I bring this the 95% also more efficient now? Because that can give more impact than the normal leaks into the atmosphere here now. So this is where, if you see that now, why we are going for even though we use the lowest global warming emissions using, but that can consume more power. So that means indirectly it is in short helping it is going to give more trouble to us now. Okay. So this is where we need to really completely thoroughly test each and everything before we jump into any conclusion here. So if you see that now environmental impact, what we are talking is sustainability is related to the easy to manufacture, because it is not only manufactured in one country, it has to be manufactured in all the countries now. So potentially it should be available for more than one source. And in addition to that, now it considerably using natural refrigerants and appropriate feasible now. The cost, of course, it should be refrigerant itself, equipment should be used refrigerant, and installation and maintenance and storage. It should not be a special type where I need to have a special man to handle this whole thing. Of course, we have discussed on the safety and flammability and as well as the toxicity. The performance, because highest efficiency is that is where we talked about 98% TWI. That should be the very, very important is there. The thermodynamic property of the refrigerant should be very high. Okay. The properties itself, you see that now that same print, if I have to replace, I need not, just for replacing, I need not replace the compressor, or I need not replace any other allied components over there now. So it should also, especially on the oil and other things, that should also be property helpful there. Then the choice of the refrigerant is not obvious. Not all low GWP refrigerants are the best choice today. That is what we are coming to here. And high efficiency performance is a big factor, that 98%. That is where we need to focus more here. And over the life of the unit, better efficiency will be the far greater impact than using the low GWP refrigerant here. But just retrofitting to a low GWP refrigerant may possible it may also be counterproductive. That is what we had discussed earlier. So in many cases, staying with 134A and 410A may be the best options available currently. So as we have sufficient time here, okay. So if you see that the refrigerant options now, sorry. Yeah. If you see the refrigerant options now, okay. So you see the left side is completely, if you see the buckets now, there are what is the GWP of the individual refrigerant now. But whereas if you see, there are many red. The red one is basically on the high flammable is there, and some are high toxicity is there. So while selecting that, now we need to have the one which one is suitable for our operations here now. So for instance, now 134A, like, so we have currently 1234 is there available now. But whereas even with the less GWP of 150, but it is refrigerants are available with R60A, R12370 are available, but with a higher flammable is there, whether I can use it for my application. So these are all the things which engineering and the manufacturers are already validating, and then after taking all this consideration only, now people are launching the new product here. So for instance, 290 R290 is one of the very good refrigerant, and also with the lower GWP, but the butane handling the butane is very high flammable, so we are unable, we cannot use it. So like to like replacement cannot be possible here in that case. So regulatory pressure to eliminate the high GWP refrigerant focus has been on the new unsaturated fluorochemicals. If you see that now, that the latest one, which people industries are already started using it, HFOs, especially 1234YF and 1234ZE and 12333ZD. So HFOs has very low GWP levels, or only mild, some are mildly inflammables, and except R123ZE, which is we call as A2L, and belongs to a group of low density refrigerant, because the low density refrigerant require the more. So that's why centrally we use it on the centrifugal compressors here now. Okay. So the replacement options. So if I have, okay, how do I future think of replacing all the HFC, which the regulator is intended to do it now. But here, if you see that now, 1, 2, 3, 4 is that that is the only thing now, which is the simplest one. But whereas if you see that down, so the GWP versus the toxicity, the safety portion. So this is where the people are really going into the lot of testing, and is already going on in the industries now here. Okay. So there currently, if you see that now R32 are already being used, or 454B is some of the manufacturers are using this, but where over and above 1234Y is already there, 1234ZE is there already there, and R513 is there, which is, we will see that now what are the equivalent which is available for this now. So if you see that by system pressure versus GWP and the safety rating now, so you can see in the range of 1500 GWP. Now low pressure is 1234 ZE and R514A, R123. These are all the replacement for R123 currently available now. And medium pressures, like say if I have to replace 134A, say the R513A is available, and over and above 1234YF, 1234 ZE equivalent. These are all with the medium pressures ranges. High pressure range, like for 410A replacement. So this 544B is available now. But I54P is with a you can see the mild flammable, and whereas if you see that why we still be hanging around 134 410A is basically one of the best refrigerants now available in industries now as on today. Okay, that we'll see now. See, you can, if you see that the classifications, and there's the on the excellent refrigerant is 134A 410. The replacement is, there is nothing is available to replace just like to like, because nothing can beat here. No flammability. It's a no ODP. Moderate ODP is there again with the 134A, and no glide. Multiple current future use. Good thermodynamic properties. The same way similar to R420A. No flammability. No toxicity. No ODP. Imagine. So just to replace this to hit the like to like. it's industries are finding difficult to correlate. Somewhere we are compromising and trying to bring it to the nearest specifications now here. Say for instance, 134A, now potential substitutes are currently R513 is there and 1235 there. You can see that the specifications of this, what is the safety class here and what GWP for the individual now. Okay, 134A with a higher 1430 GWP, but whereas equivalent nearest one is around 631. But if you go for WAR 1234 ZEE, it's only 0.97. GWP is very less, but it comes with a again safety class of A to L now. So this is where we need to balance between which one is best suitable for my application, and without changing doing any much changes into my existing systems. And in the long run, it should be there for me to use it, because we are not going to replace just straight away one-to-one. So this is again 410A replacement currently is there. 454B, many people have started using it, and of course 466 R32 is people have already started using it here. You can see that the comparison of this here. Some are blend, some are simple, some are oleal, HFO. So here we have to be very careful with how much is the glide is also there here. And a better path is we are not throwing away the current HCFC refrigerant, especially for 134A, 430A, because in India at least we have some time is there, and we both for manufacturing and as well as for the servicing of this equipment. But overall, moving forward, we definitely we need to find the best alternative or the substitutes basically for these two refrigerants. Now the industry is already moving for that, and they already started using some of the refrigerant, but of course with some penalty, and we are still continuously using it now. But there are a lot of R&D work is going on globally, and people are trying to bridge a gap between how we need to go for the nearest and ideal refrigerant for this now. So before beware of that, what you are changing to current refrigerant, maybe later good, we maybe had a good refrigerant also now. Okay, so this is the equivalent. If you see that low pressure options for assuming 123, for if 123 I can go for 123 ZEE and R514A. Okay, so this is there are no drop-in refrigerant directly available here now. Basically RY514 potential retrofit for R123. But with some compromise, because the efficiency and capacity, maybe some losses will be there, and of course toxicity is there with because that comes under B1 category here. Okay, but whereas 123 ZE is neither flammable nor toxic, more efficient chiller refrigerant, requires a new design. So this is where challenges here over here. The medium pressure is there with 134 R513 and 1234 ZE as on today. You can see the pros and cons of each and every refrigerant now. So if you see that R134A with the R513A, so is similar capacity R513, but there's no glide. Yeah, yes, may need some changes here. It can use on screw and centrifugals. The positive pressure GW is also 631, and the safety class is A1. So that's one of the good one. And of course, cons is efficiency loss is there. A moderate GWP, probably it may come with a higher cost compared to what 134A. And if you see that 123 is 4ZE, it's a pure with a safety class of A2L, very low GWP. Screws and centrifugal you can use now, not equipped with the A2L, yes. And similar efficiency of R134A, a single component, ultra low GWP. Mildly flammable, but need 30% larger compressor, probably higher cost. So this is the comparison with the medium pressures now. With the high pressures for 410A, we have that 454B. Of course, that is with the compound with the mixture of R22 or 134A. Both HFC and HFO mixed together formed a new R454B with a safety class of A2L. GWP with 466. So potentially, probably with higher cost, with the low flammability, you can go for it. And same is 466 also, neither flammable, not toxic over here. The classes is CFC issues. There are no real drop in, no replacement straight to straight 410 as on date available. Okay, so if you see that the blend composition of each and every refrigerant which is currently being considered, so this is how it is now. So 410A is basically 50-50 of R32 or 125, but whereas CP454B is R32 with the R1234. So let's not go into that. This is a blend that we're currently being manufactured by the different manufacturers. So what's the options available for the equipment owners now here? Do nothing, because we have some time to still wait for, like everybody is waiting for the good substitutes. Or if anything is only because currently with the trends are really changing now, suddenly the warming is too high, and if all the classification changes, so we may have to do it at the faster rate. So at the time, recover the refrigerant, we can still reuse it now because we have time for the servicing purpose. The maintain and preserve, but this is where now the maintenance team should have take care, but not to allow even any single pound of refrigerant should go into the atmosphere as much as possible to increase the maintenance schedule and everything and all, inspection schedule and all. And then refrigerant, if you really have good available, same to same, moving forward, so then we can go for retrofit, we can do it. Or if really the cost of retrofit is new equipment is much better than retrofit, then probably we can go for the higher efficiency equipment replacement now. So that is where the currently industries are practicing and following now. So here, the whole question is ultimately there are no real drop in refrigerant here now. Changes will range from minor to major, because maybe you may have to change the aerodynamic of the compressors, oil, materials may have to be changed, tubings not optimized for new refrigerant. Sometimes software and controls also need to be changed to use the new refrigerant now. The machine will work, but definitely at a higher price or some cost now. So retrofit sometimes definitely may cause capacity or efficiency loss. Changes to the operating envelope, especially on the compressor envelope, it will be changes over there now. Okay, so for that, this is where you need to balance and validate between the new equipment versus the retrofit now. Okay, but there are some time available still. If you've seen the history, when we started the history, we have started with the history of natural refrigerant like ammonia and CO2 now. But here, currently, there are a lot of talks, and even the experiments are going on now to reuse the natural refrigerant. But of course, that natural like ammonia and CO2 and all, currently we are using in many places. They are using in refrigeration applications now. But is it possible with a lot of safety and other concerns to use it on the refrigeration and air conditioning also? Already thoughts are going on, discussion, and as well as experiments are going on because these are all very high efficiency in the thermodynamic and with a cheaper cost available and with the low GWPs available all. So this talks also currently the major industries and the scientists are working on it now. So this is what as it is currently on the refrigerant now. Thank you very much, and I will, if any questions are there, we will invite. We can try to explain as much as possible. Otherwise, we'll definitely respond to you. Yeah. Is there any questions? Tapas, can you hear me?
Hello. Yes, sir.
Yeah, can you hear me? Yeah. Okay.
We can hear you.
So yeah, we can take any questions if it is there.
Just a second.
Actually, we have some question in Q&A section, sir.
Yeah.
So I'm going to take one by one, 2 questions we have, or I request the audience, if you have any question, to please put on Q&A section, we'll take it. So first question is, which one is the best choice for LEED certification?
LEED certification. Yeah. Okay, yeah, there are points are available for this thing. No, so this is where I was telling about the one is that the 2% which is the direct leaking, whereas the 98% what we are talking about the total efficiency which we need to work on it now. So currently, if you really ask, there is no drop in direct replacement currently available now. If you really see, or whatever we are taking, the direct replacement is not giving same to same efficiency is not available now currently now. So the best way is to go for to address our existing, check what is the current efficiency level of all the equipment, even with R410 or 134A equipment available. You need not really go for new refrigerant. Rather, you can see whether what best we can do it to bring this improve this efficiency and bring the power consumption here. That can be done by proper inspection, audits, and then work with the whoever suppliers, manufacturers. We can do it. That will also add your points into their existing. There are many buildings, many industries have already undergone into this existing itself now. Just that we need not just for going for replace the existing refrigerant with a new refrigerant and then you will get marks. But that of course that is going to come with a higher cost. But there is no like to like straight replacement available as on today.
So should we move to the next one, sir?
Yeah. Yes. If they're okay, we can move it.
Yeah. So any alternative for domestic refrigerant?
Currently, I think R32 are being used by some of the manufacturers. Okay, and we need to wait and watch. Basically, it's the initial stage. People only started using as a replacement, but that comes with a little safety concern. Yeah, no doubt. Always manufacturer will take care all the necessary precaution and safety on this handling this refrigerant here. But currently, I think very few manufacturers are using R32 for the domestic purpose.
What are the pressure classification value of refrigerants for low, medium, and high pressure systems, sir?
See, low, anything below the atmosphere, we called low. Okay, see, for instance, anything with the working with -5 inches of vacuum. So we call it a low pressure. See, for instance, R1, 2, 3, 4 is at E. So that's work with the centrifugals. So that generally work with the say around -5 inches of mercury. Okay. The medium, if you see that it's a 134A comes under a medium pressure. So with the 35 psi suction and discharge of around 120 maximum or 100 psi, 110 psi, that should be medium. If you go with the R410, so these are all high pressure ranges. So that is the only thing currently it is there. So we can classify it with the pressure.
Sir, till the date, lots of research has been on geotropic refrigerants, but still the industry is never manufacturing those refrigerants like HFE 7000, HFE 7500.
True. Very, very true. I think, but I can only tell that a lot of experiment and exercise are done, especially in Europe and other countries, which we are understanding it now. But forget about this. Currently, there are dozens of very big companies have put a lot of billions of dollars in this now on this research in developing these new refrigerants. Okay. This is one, what you said is right. like this, hundreds of combinations are being tested, and people are keep on testing in their factory, and it is being tested at the field level. And of course, what we told around the 7 categories is very, very important before they launch in any refrigerant now. It may be a very good in thermodynamics, but if you see the toxicity, and if you see in the flammability, if that is not meeting the regulatory requirement, so it may not be really success now. So like that, so if you see that, that's why I shown you that 7 criteria is very important in before selecting any refrigerant now. So not only one. So the industries are testing. There are many combination formulations and everything is being done now. And hopefully, I think we will get now. See, if the development of HFO is only based on the lot of research done with various combinations, blends only now. So hopefully, we will get a little more new refrigerant in the coming days.
Yeah. Can we use R1234YF for domestic refrigerators in India as an alternative refrigerant to R34A?
R134A, not yet done, but I have learned that there are many testing is going on now in the many manufacturers are doing the testing it on this, but not in the real market. It has not come out in the market.
I think it will be elaborate more on 2% / 98%, how this has calculated.
Yeah, okay, so I will, let me see. Okay, see, the 2% what we are talking is basically whatever the leakage, direct leakage, you know, that this leakage, assuming that I around 100, maybe around 100 200 kg refrigerant leaks, that goes into the atmosphere. So that is creating an impact, including the global warming and as well as ozone depletion. Okay, that if you see compared to the 98%, the same refrigerant, if I have to use it, if I have to run these chillers with a different refrigerant, but which has got with a higher thermodynamic properties, where the efficiency, if I use the refrigerant, that can give more energy efficient. So, and to run that chiller or to run that equipment, I need to have only less power consumption means. So imagine then over a period of this, like the life cycle, assuming that any product maybe around 10 to 15 years, if that particular one, if I use it now, that 98% is the amount which we are going to save into that now. It's a little bit calculation we need to do that. Basically on the, it only address that I need to have an energy efficient chiller or energy efficient equipment, one, and second, I need to maintain it so that now at all conditions throughout the life of the equipment, I need to maintain it so that it doesn't consume more refrigerant, more power. Imagine to produce that power, I need to spend a lot of energy, including from generation. So to make that 1 kilowatt, now how much is the generation? The electricity is being including coal. You see whatever when they make the how do the energy maybe hydel anything, they spend a lot of energy into produce that now. So even if I save 1 kilowatt in by maintaining properly or by using the energy efficient equipment now, I am not heating up, I'm not contributing any global warming indirectly. See, that is called, we call indirectly. Direct is only emission, but indirectly, if I use the less efficiency equipment in the field and then keep on consuming more and more power. Imagine now, so I'm contributing more global warming than the normal one. So that is one, we said we need to address 2%, we need to address, no doubt about it. Okay, but that is in our control. If I have a proper checklist and if I have a proper equipment installed, if I maintain properly, I can control the 2%. Whereas the 98% is the industry's challenge today. If you see that you visit any place, we are in the service field, we know that how much energy we are wasting on a day-to-day basis imagine in India, if the whole how many billions of energies we are being consumed on a day-to-day basis. Even if you saved 5% of that energy, 5% that goes into the megawatts of kilowatts we can save. So this is where the more focus we are targeting now. Hope I explained.
Yeah. Next one. So what is the ODP value of R407C?
407C. One minute, let me see. One minute. ODP or GWP?
It's written ODP, sir. ODP.
ODP. Okay, hold on 1 minute. Hold on.
I think it is a little bit clarified. PTQ, sir. I mean, PTQ.
PTQ, huh?
Yeah.
What is it for PTQ means?
One answer in chat box also from Akhilesh Arora. ODP of R407C is 0.
0. Oh, okay. Okay, thank you.
And Mr. Suresh Babu is asking again PTQ about PTQ.
PTQ. So can I ask him to explain what is the can you elaborate that what is a PTQ?
Mr. Suresh, can you elaborate what is PTQ in chat box? Or should I allow him to speak in this forum, sir?
Yeah. Yes.
Okay. Just a second.
Yeah, no issue.
Yeah, Suresh sir, you can speak now. Hello.
Yeah, Mr. Suresh, please go ahead.
Hello. Suresh sir, can you ask your question directly? Hello. It was TQ, sir. Typical mistake. TQ. Hello.
Is it anything in the presentation? Probably then we can explain to him. TQ.
So anyway, we'll look forward.
Next
question. Should I move to the next one? I mean,
yes.
3 questions are still pending. That was what I look at it in the chat box. What is the abbreviation of E2L? What does R22 manufacturing cell be stopped, sir? When does R22 manufacturing cell be stopped, sir? How harmful the low or negative pressure refrigerants are to atmospheric? There are 3 questions left.
Okay. So what is the first one? You can just.
First one is asking for the abbreviation of A2L.
A2L.
Yes.
Yeah. Oh, okay. See, if you see 1 minute, I will. Okay. Now here, if people can see this.
No, right now I think.
Okay. No, don't worry. I will explain it. See, I was showing in the refrigeration classification on the safety. In that, if you see, there are 2. In x-axis, we have shown the toxicity, and the y-axis we have shown the flammability of a refrigerant. Okay. A1 is the best. That means the toxicity level A1. Okay. L is the flammability. That means A2L means A2 is the the toxicity is a little higher, but the flammability is low. If you see, some are B2L. So that means B2 means both toxicity and flammability, both are there. You have to see with reference to the axis, x-axis and y-axis, both we have given. If you see that, so that will be there in that. So it's a classification, refrigerant classification on the safety concern with respect to the flammability and the toxicity of the particular refrigerant. So it comes under ISHRAE 34, and if you go for EN 378 classification, you can see in that you can very well understand. Okay, next one.
Next one is I think when does R32 manufacturing shall be stopped? So is it possible to answer you? I mean,
I think new equipment's already stopped, but servicing is continuing. So I think that also we have seen that if you see that the Kigali amendment, we have given up to that. So up to HCFC, we are there up to 2028 is going to be the freezing date. After that, so we have to stop everything and only consuming less 10% of like that. So we have to keep on reducing that now. So currently new equipment stopped, only the servicing, it is allowed for servicing. Yeah. The third one.
Yeah, this is the last one. How harmful the low or negative pressure refrigerants are to the atmosphere?
Harmful means I really see any refrigerant, if you really accept that 0 ODP and anything which other than 0 ODP and any other refrigerant which goes into the atmosphere, it is going to harm the atmosphere in terms of both ODP as well as ozone issue and as well as the GWP. Both are there. Whether that is irrespective of whether it is low pressure range or it is in the high pressure range or the medium pressure range, because ultimately it is a gas. Okay, what we are talking low pressure is only during the working. That means it is standing pressure with respect to the atmosphere. We are only talking that. So this low pressure, generally low pressure, it doesn't leak, because when it is leaking, the air instead of gas is coming out, air will go inside. So generally you don't get any leak except in high side. If you have a leak in the high side, yeah, you may have some leaks in that, but it is giving same harmful effect with same equal to your medium pressure and high pressure. There is no changes because of it is low pressure. I think
one more question is left. So should we take it, sir?
Yeah, please.
Yeah. So any software to calculate the thermodynamic properties of blend?
I think it's a very big subject if you really go into that. Okay, there is no software available, but there are every refrigerant has got a thermodynamic property. If you go and see its pH chart itself is more than sufficient to find out the thermodynamic properties of any refrigerant. So if you ask the manufacturers, so generally they provide this the pH chart, Molière chart, we tell that. Okay, so in that it is available. You can calculate complete refrigeration effect, efficiency effect, and everything. You can see that in that. So it should be available from the manufacturers.
I think one more question is he wanted to know about hydrofluorocarbons.
HCFC.
Yeah.
So what is that you want to understand?
Just only written HCFC. I don't know what the question is exact, okay, but
let's see,
only received the message hydrofluorocarbon at HCFC.
Okay. See, there are many hydrofluorocarbons now. See, R134A is hydrofluorocarbon. Okay. So like that, there are many. If you see that 143, 245B, 227, there are many, but we don't use so many HFC in our air conditioning industries. We use only 134A. But there are many other industries like the foaming and other industries which uses this kind of refrigerant for other applications. So they are also coming under the same threat. So there are around, I can see around 20 HFCs are available in the market. Okay, but we are using only one. That is majority is 134A. And I think that's answered this question.
R600A is R600A can be used in chiller also. It is highly flammable. I think someone.
No. Why you wanted to
chiller? It won't be used, right?
why you should take a risk?
Okay. So I think it was a great presentation from your side, sir, because what we observed that many of the participant was active and they asked their questions. That shows that how interested for this webinar they are. What we observe ki if we get many of the questions, that means they listen very well and ask their question as well, and you have elaborated so nicely. So I think few more sessions are required for this topic. What do you believe, sir? I think, am I right?
Yeah, true. Absolutely. No, it's only a beginning. What I can say, the industry is every day. It's like my friend always used to tell. Today you are holding a mobile with you. By the time you started enjoying, there is another new mobiles already in the market. Okay. The same way now on refrigerant, it's happening like that today. So today somebody is developing a good one. Then the next day I'm finding that there are some other equivalent or better refrigerants are coming in the market now. So that is where we were telling now, please wait and watch. So we need not jump.
So can we make a program series or anything regarding the refrigerants or green refrigerants? I mean, for the future programs.
I think in refrigerant, I think this is, we have given the updated latest whatever available in the industries with respect to the Indian market. So if we really go a little more depth, that maybe for European countries, so that will be too big. We cannot understand that, because there are stringent regulations already in place. Okay, but not for India. So let's not wait into that. It will take at least another 10 years to have an effect in India. Okay. So but you can discuss it. The Earth Day is, I'm telling you, Earth Day is refrigerant is one of the subjects. Okay, but if you really see that 98% what we are talking, that is really contributing more heat to the earth. If the industries, I'm talking, we are also a part of industries. If together, if we start attacking that 98% now, I think that the global warm effect can be reduced as soon as possible. That is very important. So the industries understood, realized, and that is where if you see that Green Building Council and all those things and all, why they are acting on that. It is only because of that they realize that yes. So in industries now, buildings consumed more power, and in that building, and again air conditioning consume much more power. You can say around 30 to 40 to 50%. So there, if you address, I think a lot of things can be addressed, especially on the earth warming up. Basically, we are telling green building, whatever you're talking now, the green earth or Earth Day. I would suggest you, if you can arrange some something on the maintenance, if anybody can do that. So how do we save power? So if you can ask someone to do that, so that will be the good for a air condition. I'm sorry, for the earth. Yeah.
Definitely, sir. I will discuss on this after this workshop.
Sure.
Or we can find a good speaker, or you can be there, whatever. I mean, we'll look after this. This is definitely a great topic, what you suggested, and definitely will make it, sir. And as we all know that the chapter or any chapter of ISHRAE is the main theme is to disseminating knowledge, and members are the key strength of any of the society. So I request one who is non-member of ISHRAE, they can join ISHRAE directly through, I mean, there is a website called www.ishrae.in. When you go over there, you can find the link join ISHRAE, and there are very nominal fees what we deliver against that. I mean, there is an option to join ISHRAE, and you will find many of the things after joining this. You can enhance your knowledge. You can get the good network over there. We have many of the physical event going to happen. I mean, after the pandemic, we have started very well, and all the chapters are doing great in the physical event as well. So the nearest, I mean, whatever suits you, you can join over there. For Delhi chapter of ISHRAE, you will have to just select in the membership Delhi chapter of ISHRAE. Then you will have to put up all this detail and submit button and payment option. You will find out, and very easy process is there. Very user friendly process is there to join ISHRAE, or you can join offline as well. You can contact me, or any queries related to this webinar, or any questions left. Because of the time constraint, we cannot take. I think we have taken most of the question. If anything is pending, you can send it to us at admin@dcsra.org. Your question will be well taken, and this will be forwarded to the speaker for the day, Mr. Ganeshan, and we'll send you the answer. So coming to the end, any final words, sir, you want to share in this forum before vote of thanks?
No, I'm very much thankful for ISHRAE Delhi chapter for organizing this, the needy topics that you have selected. And we are very happy to share whatever little knowledge we have in this, like to disseminate the knowledge is our core team. Thank you, and thank you for all the participants. In fact, now we always enjoy when the question comes, because that will refresh our mind. We always we may not able to answer all the questions, but sometimes we also go and find out what is the answers and all. So that helps us now. So thank you for all joining and be a participation in this now. Thank you so much.
So, thank you, sir. And first of all, I would like to thank Delhi chapter of ISHRAE to giving me the opportunity for vote of thanks of this such a great session. And this is just a start of Earth Week, what Delhi chapter is celebrating this week from this webinar. So many other programs as well. I will mail to our members who have already made and keep you informed. So for this webinar, we are thankful for first of all, the speaker of the day, Mr. N. Ganeshan. They have enlightened us with this their great knowledge, and it was such a nice session. They have elaborated very well. We are thankful for all the participants. We are thankful for all the partners: platinum partner Armacell, gold partner LP Reflex, silver partner Briar DRI System, annual silver partner Advanced Wall, annual partner Standard Refrigeration, and Paramount Quality. And altogether, it was a very great session. And for this session, we are thankful for all the DCI staff also, because marketing is one of the part that is being taken care by them. So finally, it was a great session, and thanks all of you to join this. And we'll keep you informed for another session, and request you to join for the further session as well. And again, I request everybody to join us, because membership is our strength, and hope we are disseminating knowledge time to time, and you can send your feedback as well regarding this program. So thank you very much, sir. Thanks for that.
Thank you. Good day to you all.
Yeah. So with your permission, I'm going to close this session.
Close, please.